So today we're going to talk about measures of variation. Measures of variation. So what did we learn in 3.1? We talked about what? Mean, median, mode, and mid-range. There's 4 things, right? Mean, add everything up, divided by the number, right? Median, stacking from low to high, go in between the middle, correct? Right? Mid-range was what? Oh, mode. Mode was what? The most common one. Mid-range was maximum, minimum, add them together, divided by 2. Right? Pretty simple. The only thing that we wanted to remember was being resistant or not.
Median.
Median is the only one that's resistant to outliers. Okay? All right? So there we go. In a nutshell, that's what we learned. Okay, so 3.2, let's talk about 3.2. We're talking about variation. So variation really means, so, does it look like this? Or does it look like this? It's really what it is, okay? So the blue one has more variation or less variation?
More. Less.
Blue has less, right? If you look at the maximum versus the minimum versus the maximum versus the minimum, right? More variation, less variation, okay? If you had to choose one that you were going to use for whatever you're going to do, would you rather have someone that has a large variance or a small variance?
Large.
I got different answers here. What?
Large.
Why do you want large?
More is good.
More is good.
It's more exact if it's less variation, maybe.
Okay. So let's think about what we're doing here. Okay, we're taking from a population, right? We're going to go ahead and do a sample, right? And we're going to try to guess from what we got here over to what's over here, right? So we're trying to use this to guess what's here. Yes, question?
Which one is the blue one? Because I see green and black.
The green is
The green one for
Okay.
you then.
I was really confused on which one you were trying to...
Okay, so based upon this, do you want more variation or less variation?
More.
more.
Which one's going to make you easier to guess this number?
Less.
Less.
Oh.
Okay? So you want less. You would prefer to have whatever sample that you got or whatever you were measuring to be less variant, right? So you have a better idea of what it could be, all right? Just kind of getting into that thinking there, okay? So if you look at page 97, there's a couple of dot plots there. There's one that says single line, the other one that says multiple lines. So what's going on here is that they are measuring the time that it takes for a customer to be served at a bank, okay? Single line meaning they have a single waiting line, right? And then you go up and there are like 3 or 4 tellers and, whatever opens up, you go to next, right? Versus the multiple lines means that each teller has its own line. Which one do you prefer? Multiple? Okay. Well, it's saying here, if you look at the dot plots, which one has more variance? Multiple, right? Versus single line is just pretty nice and packed, really compact there, right? Anybody tell me why this would happen? Huh? So let's say what could cause a difference in the time differences in any line for that matter?
Somebody's slow or somebody's fast.
Somebody's slow, right? Somebody's more experienced. They have a more experienced teller. Somebody's like it's the first day on the job, right? Type of thing where can I get some help or right, whatever. So if you get in that line, everybody's going to have a long wait. Does it make sense? Every single person who's waiting is going to have a long wait. Whereas If you have a single line, that effect gets reduced, correct? Because you have three other people who's helping out, and it works out better. Does that make sense? You get that? Okay. You also understand why the bank would actually want to do this? Does it benefit the bank? Of course it does, right? Because if the customers who had to wait like 125, 115 seconds aren't likely to come back, right? If you went to your bank and every time you went to your bank you had to wait 10 minutes to get served, would you go to that bank?
No.
I wouldn't, right? Okay. All right. Flip the page. Let's look at the range. There's a definition there. Range. The range is nothing more than maximum minus the minimum, which is what? Okay, you got the right connection. What's the relationship between range and mid-range?
Range is here, mid-range is here. Good one. Using the maximum.
No, you understand like my knowledge.
So,
You divide another one by half. You're not done.
let's say that my maximum was 100, my minimum was 10. What's my mid-range?
45.
55. Nice. Close. You're close. 50 versus the range would be what? 90, right? Okay. Are we good? All right. So that's the range. Then we go to standard deviation. What's standard deviation? Standard deviation. Deviation. We are deviating from the mean here. Okay, we're deviating from the mean. Okay, so let's use the black one. Let's say that I have a distribution that looks like this, which means that more than likely my center is going to be here. Okay, a standard deviation, there's a definition there. And Kayla, read that for us.
Standard deviation.
Mm-hmm.
Okay, the standard deviation of a set of sample values denoted by S is a measure of how much data values deviate away from the mean. It is calculated by using formula 3-4 or 3-5. Formula 3-5 is just a different version of formula 3-4. Both formulas are algebraically the same.
Thank you. Okay, so we are deviating from the mean, right? So a standard deviation. Okay, standard deviation is calculated, okay, there it tells you how to calculate it, but it's a measure of how much data values deviate away from the mean. Another way to put this is if I randomly picked a number, any number in the distribution, and I measured how far away I am from the mean, okay, that is what the standard deviation tells me. Okay, so on average, how far am I going to be away from the mean? It's called the standard deviation. Standard deviation. So standard deviation, that's your mean there. Okay, so that's how it goes. Look at the formula, 3.4 and 3.5. I am used to using the one on the top, although there's one on the bottom. Normally, I do not teach, or I do not have you guys hand to do a standard deviation, but for this class I will go over it because there are some questions on the homework that go with this. Okay, so actually what we'll do is we'll just go over and do example 2 together. But in the meantime, before that, there are some important properties of the standard deviation above example number 2. Standard deviation is a measure of how much data values deviate away from the mean. We talked about that. The value of the standard deviation is S is never negative. The reason why it's never negative is if you look at the way you calculate that on the 3.4 and 3-5, they're both a square root, right? You can't have a negative coming out of a square root. Okay, So that's why they're going to be positive. Okay, blah, blah, blah. It's 0 only when all the standard values are exactly the same. So if I have a data set that said 5, 5, 5, 5, 5, they're all going to be the same. There is no deviation because they're all the mean. Does that make sense? Right? They're all the mean because they're all the mode and they're all the median. They're all the same. It's 5. And if you look at how far away they deviate, each data point deviates 0 away from 5, right? Okay. Larger values of S indicate greater amounts of variation. Standard deviation S can increase dramatically with one or more outliers. What does that mean?
Not resistant.
Not resistance. Yes, very good. Okay, we're getting used to this statistic talk here. Okay, so they are not resistant. Units are the same units as the data values. Standard deviation is a biased estimator. Biased estimator. And we'll get into that a little more later on. A bias estimator is when I go from here to back to infer back here. When I'm looking at the mean and the mean here, it's an unbiased estimator. In other words, they should be the same. Okay, but when I go from here to here, there is a correction factor that I have to make. Okay? In other words, and we'll talk about this later on, you're going to get something like this, where the sample size is n. Okay? So there's going to be this is an n. There's going to be, huh? Oh, this guy? It's a sigma. It's a Greek S. Greek S. You've seen this before? Maybe?
Yeah.
Yeah? This is the small, this is the large, capital, large. Okay, all right. So anyway, there's a correction factor here. So you have to, there's a bias that you have to correct for. When you go from here to here, there's no correction. Okay? We'll go, just understand what it's about right now, okay? Don't worry too much about it. All right, let's go ahead and do example number 2 together. And then that is the actual calculating of a standard deviation. So make sure you understand how to do this. You will do well on the test if you know how to do example number 2. Okay, so you're going to use formula 3.4 to find the standard deviation of these Verizon data speed times. These are in megabits per second. We have 38.5. What's the next one? We have 55.6. And then we have 22.4. 14.1 and 23.1. Is that correct? So I have them correct?
Yes.
Okay, so how am I going to find the mean? I have to find the mean first, correct? So let's go ahead and add them up together. We're doing this by hand, so don't cheat. So if you add them up together, divide them by 5, what do you get? 30.74. So I get that the read here is 30s. What? 30.74. 30.74. 30.74. Okay. Now let's look at the formula number 3.4. If you look at it, it has that sigma thing again. And it looks like you're taking each data point x, you're subtracting that from here, and you're squaring it. Does that make sense? Do you see that? So you're looking at top. Yes, that's what we're doing? Okay. So there's a square here, right? So the first one is what? This. So this minus this, right? So I get 38.5 minus that. So I'm going to get what? 7.76. Square that. I'm going to do this at the very end, okay? And do this at the very end. So let's go ahead and go. So this is the first one. And the next one is this guy. I subtract from here, I subtract this. I'm going to get what? 24.86. I'm going to square that. And I'm going to subtract this guy from this guy. I'm going to get 8.34 negative. Square that. I'm going to subtract from here this guy. I'm going to get 16.64 negative. Square that. You know, from here, I'm going to subtract that. 7.64 negative. I'm going to square that. It says to add all those together. The sigma is adding them all together. So, add them all together. Divide by, what's my n? 5. 4. Take the square root of that. Okay. And if you flip the page, it did all that. They were nice enough to do all that for us. And what do we get? We get 2.7. Oh, the square root is 16.45. 16.45. 16.45. Okay, so review. What do? We found the mean, right? Then we took each point and subtracted this from here. I mean, either way, we're going to square it, so it doesn't really matter which one you subtract which one from, right? So I'm going to take this guy, subtract this, square it. Take this guy, subtract this, square it. This guy, subtract this, square it, on and on and on. And I can divide it by 4, and then I can put the square root on it. Okay, this is how I get it. So this should be the same thing that you get if you actually did the 1-var stats. So let's do the 1-var. So let's see if we can put 1, 2, 3, 4, 5 numbers into our L1 and see if we can do the 1-var stats.
Where?
Which one do you do? Those numbers?
You
do the top one.
L1. So go to stat edit and populate these 5 numbers into your L1. You found the 1-var stats?
It's
Stat calc?
no, I found which like data point this is.
Oh.
What is it?
Wait, with the squared or without?
What?
With or without? Just the
Oh,
No,
no,
no, I want you to do the 1-var stats.
16.4.
Okay.
It's
You got it? Same thing? And you got this?
yes, no more problems on this. Never seen that ever again.
So yes. So if I put this on the test, right, and you do the 1-var stats, okay, you're going to get full credit.
Oh.
I thought you were going to say one thing.
Yeah.
Okay. Do you understand? So it would be nice if you knew how to do 1-var stats, I think, right, rather than this. Okay. Okay, if you go to page 100, it does the same thing using the different method. Okay? And that's like way more. Okay? So you can look at that if you want to.
No, I don't.
How about it? Okay. So are we good?
Yes.
All right. So today, what did we learn? We talked about variation. Variation is what? The max minus the minimum, and we wanted that to be large or small.
Small.
We would prefer it to be small. Not that we have any control over it, right? Whatever the data is the data, right? You have no control over it. Now, Also, we need to understand what the definition of standard deviation is. You're deviating from the mean, right? So if I randomly picked a point from the distribution and I calculated the distance from that point to the mean, on average, that is what the standard deviation is. Okay? All right.